Hello, welcome to another video of detailed math solutions. In this video, I'm going to prove that the following equation is true. A plus b plus c squared equals to a squared plus b squared plus c squared plus 2ab plus 2ac plus 2bc. Let's begin with the left side of the equation and write it down again. What I'm going to assume is that the first two terms, a and b, make one term for me, or I can write this down as a plus b in parentheses plus c squared. Then I can apply the formula for square of binomial sum, which is a plus b squared equals to a squared plus 2ab plus b squared. I've reviewed in this formula in some of my other videos, and I'm going to include a link to it in the description below, in case you'd like to check it out. Using this formula, in our case, the first term would be a plus b in parentheses is going to be our first term a in this formula, and c is going to be our second term b in this formula. In other words, this will equal a plus b squared plus 2 times a plus b multiplied by c plus c squared. When we apply this formula, this is what we get. As a next step, we need to open parentheses. Again, we apply the formula a plus b squared equals to a squared plus 2ab plus b squared, and then open parentheses. This equals to 2ac plus 2bc, and what's left is c squared. Or if we order these a little bit differently, a squared plus b squared plus c squared plus 2ab plus 2ac plus 2bc is our final expression. In other words, so far we proved that a plus b plus c squared equals to a squared plus b squared plus c squared plus 2ab plus 2ac plus 2bc. This is another widely used formula in algebra, and it's helpful to be memorized. Thank you so much for watching. I'll see you in the next video. Bye-bye.